So here we have the 2014, this is question 15, and we're given a diagram, so I'm just going to draw that out quickly. So my diagram is not drawn with a ruler, but the one you're given in the booklet is it's drawn out, so it's a lot better. So I just don't have a ruler right now, so I'm just going to draw them roughly. So this point here is B, this is A, and this is O. So it said, write in the coordinates of point A and point B on the diagram. So point B, the coordinates will be our X and our Y point. So we have to figure out how much do we go across on our X axis. Well, on the X axis we go across 4. So for B it's going to be 4. But for our y-axis, if it hasn't went up or down, so it's just going to be 0. If a point is on the x-axis, the y will be 0, so 4, 0. And this one, if we want to know how much it's went across, it hasn't went up and it's on the y-axis. So if a point is on the y-axis, the x point will be 0. And then the y point is 3. So if we want to get the distance AB, well, what we can do is we can use our distance formula. So the distance formula is x2, so it's this one here. So x2 minus x1 squared plus y2 minus y1 squared. And we just have to label one point x1, y1 and the other x2, y2. And it doesn't matter which one we label as which. So I'll call this x1, y1. I'll just say that this is point B and this is point A. So this is x2, y2. So x2 minus x1, so 0 minus 4 squared plus y2, which is 3, minus y1, which is 0. And that's squared. So that's going to be minus 4 squared and then plus 3 squared. So a minus 4 squared is going to be 16, because a minus by a minus gives me a plus. And 3 squared is going to be 9. So that's going to equal to the square root of 25. So that's going to equal to 5. So that's the distance AB. And then it says write down the distance from O to A and O to B. So if we look at the distance, well, it's just going to be a straight line from O. It doesn't give us a lot of space to find this, but the distance from O, say if we had a line here, we'd have to use the distance formula to figure out the distance. But say if we had two lines and they were both on the same level, it had just went across. Or say if we had a line like this that was absolutely straight, it had just went up. So the distance from O to A, it had literally just went 1, 2, 3 on the y-axis. So there was no x movement. So the distance was just 3. And this one here, so OA is 3. So say if you have a straight line, we can actually just count. But if it's anyway slanted, we have to do the distance. And from here to here, it's 4. So OB is 4. So if it's exactly horizontal or vertical, we can just count. And then use the theorem of Pythagoras to find the length of the hypotenuse OBA. So if you want to find the hypotenuse of the triangle, so if we want to get the hypotenuse of this triangle, well, the hypotenuse is going to be AB. So we have already kind of got this, but they want us to use the theorem of Pythagoras as well. So if we say deal with this triangle, so it's a right angle triangle. This here is 3, this here is 4, and we want to find the hypotenuse. So this is the hypotenuse. The hypotenuse is going to be always the longest side of our triangle, and it's going to be opposite the right angle. So if we want to use the theorem of Pythagoras, so say if we had a right angle triangle, and I'll just call this A, B, and C, the hypotenuse squared, so C squared, is going to be the square of the other two sides. So the hypotenuse squared, let's call it x. So x squared is going to be 3 squared plus 4 squared. So x squared is going to be, 3 squared is 9, 4 squared is 16. So x squared is going to be equal to 25. So if we have what x squared is, well, if we then have to get the square root of both sides to just get x. So x is going to be equal to 5. And that's the same answer that we got from using our distance formula. So that is our answer for that. Thank you.